Okay, Mikey, you got your wish. I'm going to do a couple of these, not all of them. So for number one, we have our position function. We want to know when is the object moving to the left. So that tells us that the derivative, the velocity, has to be less than 0. So for part A, we need to know when is the velocity less than 0. So first, figure out when the velocity is 0. So we get 6t minus 12 for our velocity. We want to know when that's 0. So if we add 12 divided by 6, we get t equals 2. But we want to know when is it negative, so we have to look at our number line. We know the velocity is 0 when t equals 2. We just need to substitute a value into the left of 2 and one to the right of 2 to figure out when it's positive and when it's negative. If we put 0 in for t, then we would get a negative value out. If we put 3 in for t, we're going to get a positive value out. So the object is moving to the left when we're from negative infinity to 2. Right? That's when the velocity is negative. So from negative infinity to 2. For part B, when is the acceleration positive? Well, acceleration is the second derivative. So we have to take the derivative of 6t minus 12. Our acceleration function is just 6. So our acceleration is always 6. There's no variable there. It's not changing at all. So acceleration is always positive. So it's always 6, which means it's always positive. You don't necessarily have to write that part, but we can write that it's positive from negative infinity to infinity, all real numbers. Alright, you're on your own for number 2, similar to this one.